So at this point, we're almost done with template-driven forms because you did learn about its key features now, but there is a bit more we can do with it. For example, we might want to reset the form once it has been submitted. And we could easily do that by using this form data object we're getting and by accessing the form in there. And then here we can call reset. And this will do just what the name implies. It will clear the input values and that's important, it will also reset all the internally managed information about the form. So whether it's valid or not, whether it has been touched or not, this will all be reset as you would expect. Because of course, if the form is submitted, it should be treated as pristine and untouched again. And that's also what reset will do. In addition, it's also worth mentioning that you can see that there's a lot of other information in that form object and also some other interesting methods you might want to play around with. You could, for example, mark a form as dirty manually from inside your code if you had a use case where you need to do that. Angular will manage it for you, but if you want to overwrite Angular's behavior at some point, you can do that. You can also add or remove validators programmatically if you needed to do that. But these are, of course, also some more advanced use cases because typically when using the template-driven approach, you want to do all the setup and configuration inside of the template. That's the idea behind this approach after all. And you'll learn about an alternative approach soon. Nonetheless, it is worth knowing about these properties and methods here, and I can only encourage you to play around with them. Here it's now reset, which I want to call, and with that being called here, if I save that, if I enter some valid values here, and I click login, you see the inputs are cleared, and you see that, for example, now this is treated as pristine and untouched again, as you can tell by these classes, because as I mentioned, that is what Angular will do if you reset a form. Now, to conclude this template-driven approach here, I want to enhance this login component by adding a little bit of a more advanced feature to this component and this form. Because I want to make sure that if a user visits this page and this form, if they enter a value here and they then reload the page for whatever reason, I save that value that they entered and I repopulate or I pre-populate that form with that saved value. And that therefore in the end means that as a first step we must save that value whilst the user is entering it. And then if that page loads and if that component here loads, I want to pre-populate this form with the saved value if I have one. Now, let's start with saving that value. To do that, I need access to this form outside of onSubmit because I want to start saving right from the start when this component becomes active, not just when the form is submitted. There, it's too late for what I want to do here. So therefore here I'll add a new property called form, and I'll use the viewChild function to populate it. And you of course learned about this function before in the course. We can use it to get hold of that form object in our template. So I'm using form here as a selector to select this variable and the object stored in there and get access to it in my template. So form here is now that form that is created by Angular, this form data object here. And therefore viewChild will in the end give me an object of type ngForm here. This then allows me to add the constructor and use after next render, a function about which you also learned earlier in the course, to register a function that should be executed once this component has been rendered for the first time. And I'm using after next render because this form since we're using the template-driven approach, is created with help of the template, so it's only after the template rendering that this form is fully initialized. That's why I'm using this after next render hook here to interact with that form. So inside of this after next render function here, I can then get hold of that form and read it like this. Since I'm using the viewChild function, this is a signal, so I need to read it like this. And then there I wanna be notified about any changes the user makes to the form so that I can save that information somewhere in the browser. Now it turns out that Angular gives you a value changes property on that form object. And that then gives you an observable, a feature about which you learned before, and a feature which I mentioned would be used from time to time in certain parts of Angular. Well, value changes now is such a part that does use an observable. And we need that question mark here since TypeScript is not convinced that form will yield a value here. We could change this by changing this to be a required viewChild. With that, we can get rid of the question mark. So now value changes gives us an observable, and we can subscribe to that to be notified about changes. Because this is an observable set up by Angular that will emit new values whenever the values entered into the form change. So essentially on every keystroke the user makes. Now here a question mark is needed as well because, again, this could be undefined, it could be null, and therefore we need a question mark so that subscription is only set up if value changes exists, so if this observable exists. Because it might not exist if the form hasn't been fully initialized yet. So we can set up this subscription, and we can pass our observer object to it, and then register this next function that will be executed for every new value that is emitted. And I shared more details about observables and this next function in that earlier RxJS course section. So definitely take a look at that if this is all brand new to you. Now here we'll get that value that is omitted, which here is of type any. And therefore here for the moment I'll simply console log it. And of course, since I call subscribe here, I'll get back a subscription, and I want to clean up that subscription whenever this login component gets destroyed. Because even though we never destroy this component anywhere, it could theoretically be removed if we change our application, and to then make sure that we don't have some ongoing subscription which we don't need anymore, we should always clean up our RxJS subscriptions. So here I'll get my destroy ref with help of inject destroy ref. And then here in after next render, I will use this destroy ref on destroy and call subscription unsubscribe like this, if the subscription exists. That's why this question mark here is needed. Okay, so with that in place, if we now save that, you'll see I get some output initially here when the form is initialized. And now if I start typing here, you see with every keystroke, I get an updated object. And that's also interesting. You see that the value we get here in our next function is in the end an object of this shape. An object with an email property and a password property. Now in this case here, I only want to save the email because saving passwords doesn't sound like a secure idea. And hence, if I want to do that, I need to access value.email. And I now want to save that in the local storage of my browser. So here in this next function, I want to access window.local storage to use the browser built-in local storage feature, which is some storage provided by all browsers. And we can call set item here to save something in that storage. Now we need to give that an identifier, and I'll name it saved login form, and then a value that should be saved. And here in my case, I want to save that email address, but I'll actually save it as an object where email is set to value.email. But since local storage only accepts string values, I will call JSON stringify to convert this object to a string in the JSON format. And with that, this object should be stored in the local storage with every keystroke, and therefore it should also be updated with every keystroke. So if we now check the application tab in the browser developer tools, because it's there where you can access information about your local storage, you should see the saved login form key here with that empty form. But if I now enter something here, you see it updates with every keystroke. So that works, and knowing about this value changes observable is definitely useful. However, of course, at the moment, we're basically updating local storage on every keystroke. And whilst this is not a problem here in this basic application, it is probably easy to imagine that this might not be ideal for performance if this were a more complex application or form. Therefore, here I'll actually call pipe before subscribing, because RxJS, as you learned, offers tons of operators, which can be overwhelming, but it, for example, offers a debounce time operator. And this must be imported from RxJS. And what debounce time will do is it takes a time in milliseconds, let's say 500, and if a new value is emitted within that time frame after the previous value has been omitted, then it will discard that latest value. So it will essentially make sure that this next function doesn't get triggered if the user is still typing. Only if the user stops for at least 500 seconds, the emitted value will make it to this next function. So that will make sure that this next function won't run too often. With that, if we save this, if I reload, you see again, I start with this empty field. But now if I type here, it does not update as long as I keep on typing. Only if I then stop typing for at least 500 milliseconds, this gets updated. And that's therefore more efficient, and how we can leverage the fact that we're dealing with an observable here. But with that, let's now make sure that we don't just save that value, but that we instead also use a saved value to pre-populate the form.